Hello, our most valued student. My name is Confident. Welcome again to our session on Engineering Science N2. And I'm doing the last part on dynamics. As I said, we are revising. And as we're doing our revisions, I've already done part 1 and part 2 on dynamics, where I'm looking at the previous papers. So this is the part 3 of the lesson. I will encourage you to grab hold of the last 2 lessons that I did on the same topic. And also, if this is your first time to come in contact with our channel, I will encourage you to subscribe to our channel, as well as ensure that the notification bell is turned on so that you can be notified every time there is a new video that we're doing. So let us look at this topic on dynamics, and I again chose one question from a previous paper. I think this was a paper written in 2019. And let us look at the question. As I say, it is on dynamics, and it's question number 1. So whenever you're doing your engineering science N2, you will notice that the first question that you are dealing with is a question on dynamics. So let us look at that part. So we are looking at question number 1. So the first part of the question is indicate whether the following statements are true or false. So this is a true or false scenario. Choose the answer and write only true or false next to the question number 1.1.1 to 1.1.3 in the answer book. So what you do is you go to your paper, to your answer book, you write 1.1.1, 1.1.2 and 1.3, and from there you have to now write the answers, whether it's true or false. Now the first one is scalar is a physical quantity that has both magnitude and direction. We know that it is not scalar, but it is a vector. So that statement is false. So you have to write there false. Some students like to write F, but you'll be penalized because we don't know what is F. You have to write it in full that the answer is false. Next one is velocity is the rate of change of distance. Now this is not velocity, but this is speed. Speed is rate of change of distance, but if it was velocity, you're going to say velocity is the rate of change of displacement. Are you seeing that? So if it was displacement, you're going to say yes, that's velocity. But if they are saying the rate of change of speed, you know that the rate of change of distance is speed, because speed is a scalar quantity just like distance. So that statement also is false. 1.1.3, the initial velocity of a dropped object or a body is 9.8 meters per second squared. The first part is they are talking about velocity, but look at the units, it's 9.8 meters per second squared, which is talking about acceleration. In this place, it is the acceleration due to gravity. So this has got nothing to do with initial velocity. It is acceleration due to gravity. So this statement also is a false statement. So you can see that the answer 1.1.1 was false, 1.1.2 was false, and 1.1.3 was false. So that is that part. Let us move on to the next part of the question, so you get 3 marks for that. Now in question 1.2 says figure 1 below contains a graph representing the velocity of a vehicle with respect to time as the vehicle moves past A, B and C. Movement takes place in a straight line. So they've given us a diagram. Let us study the diagram. They're saying figure 1 below, which is this diagram. It says represent the velocity of a vehicle. As you can see, this is velocity in meters per second with respect to time, and this is time in seconds. And then it said it moved from A, but I guess this was the A part. It's not accurate, but this should be the A, that should be the B, and that should be the C. So this A is the initial velocity. From A it went to B, from B it went to C. Movement takes place in a straight line. So That is very important, meaning for that part, for that you can do your calculations, is very important, so that it's movement in a straight line. Alright, now determine the following. The first part is 1.2.1. we need to find the deceleration of the vehicle between B and C. So the deceleration or the acceleration in the negative, otherwise which means the object is slowing down between B. So this is from here to there. So if I can mark it with my marker, so they want the deceleration between B and C. So we can actually look at that. So now from B to C, if I'm looking at deceleration, remember now you have the formulas and you have to use the formulas for the equation of motion. Now let me have my formulas. Three of them is V is equal to U plus AT. The first one, the second one is S is equal to UT plus half AT squared, and the other one is V squared is equal to U squared plus 2AS. So these are the common equations of motion formulas that you are dealing with. So now they are saying we need to find the deceleration between B and C. So what you have, if we're using the first one, we are going to have V is equal to U plus AT. Now in the first part, remember V is the final velocity, now which is our C velocity at C. You can see that it is 15. So you've got 15 is equal to initial velocity U, which is 22, because that is where it was at initially, which is 22 plus A, and now the time taken between B and C. This is the time taken. You can see that it moved from 10 seconds to 14 seconds, so which is in a way bracket 14 minus 10. So what you have here, you can take 22 to the other side. You have 15 minus 22 is equal to A. Now 14 minus 10 is 4. So now 15 minus 22, if you can do that, you will have, I can choose to write this one, 15 minus 22 divided by 4 is equal to A, 4 over 4. So like cancel that. So if you use now a calculator, what you're going to have in this scenario is 15 minus 22 over 4, and then you press ST. This is the acceleration, which is negative 1,75. So negative 1,75 meters per second squared. This is your acceleration. That's why it's negative. So you can write and say deceleration, because the question was find deceleration. So deceleration, you don't have to put the negative now. It is 1,75 meters per second squared. So the moment you say deceleration, you don't have to put that negative. So if I can write my answers up there, this is 1.2.1. and we said acceleration was negative 1,75 meters per second squared. I'm using that so that I can keep my answers for the next question. So this was the first question that you get to say find the deceleration of the vehicle between B and C. So let us move on to the next question. For the next part of the question, as I say, this is just a quick revision, so you get 3 marks for that, guys. Just look at the mark allocation. I think it's a good 3 marks for you to master in that previous question. Now look at the next one, 1.2.2. it says the total distance between A and C. So they're looking for the distance. Now if we are talking about the distance in this case is area under the whole shape. So when they talk of distance, they are now referring, if I can just show you, they are referring to everything that is under this shape. So we are looking for the area under this whole shape. That is what they mean when they say distance. Why? This is a velocity time graph. So whenever you are finding distance in a velocity time graph, you must know that the distance in a velocity time graph is the area under the graph. So now when we are looking at this graph, it's up to you how you want to split the graph, but you can use the information given. The way they brought you the diagram. If you look at the diagram, if I can take this shape, they say everything is a straight line, remember? Okay, I'm failing to get the actual line there. You take that, and you take that, and you take that. The assumption is this is a rectangle. Now the area here of a rectangle is length times breadth. So we look at the area, the length, that is from this point to that point, you can see that it is 10, and the breadth, which is from this point to that point, you can see that it is 22. So here the length times breadth, it is 10 times 22, which is, I think it's 220. Now remember, we are dealing with distance, it is meters. That is the first part, you find that area. Now the second part of this, if I can choose a different pen, is to find the area of this part. Let me choose something different. I have a triangle here, and the area of this triangle, remember, area of a triangle is half base times height. So if I want to find the area of that triangle, it is equal to area is equal to half times base times height, which is equal to half times the base is this distance here, and that distance is 10 minus 14, it is 4, and the height is that distance from here to there. The height in this case, it is 15 minus 22, and if I subtract 22 minus 15, it gives me 7. So this distance is 7. So it's half times base, 4 times 7, and if you work on that, there it's 2, and then you get 14 meters. And then lastly, the last part of this diagram is the area. Remember, we have dealt with that, so now we're looking for the last part, which is this particular area here, and that, as I'm marking it there. So you can see it's more like a square or a rectangle. Again, here we say area is equal to length times breadth. In this case, which one is our length and which one is our breadth? So if you look at the area here, area is equal to, now this distance we said is 4, and this particular distance here, which is 15, so it's a rectangle, so which is 4 times 15, and then the answer is 60 meters. So the question was find the total distance between A and C. So now we are going to say total distance, and then what you need to do is to add that part, which is 220 meters, plus that part, which is 14 meters, plus this part, which is 60 meters. So that is the total distance between A and C. So you've got 220 plus 14 plus 60, and then you get 294. So this is the distance that the car traveled between A and B. So if I can write the answer 1.2.2 to say S, or distance, is equal to 294 meters. Alright, so that was the part. Let us move on to the next question. Just to erase, to clear some space. Now the next question, so this was how many marks? 4 marks, guys. Just think of it to find the area. So mainly they're checking your mathematical skills in this particular question. Now question 1.2.3, the average velocity of the vehicle between A and C. So this is 2 marks. Now they wanted the distance between A and C. Now they want the average velocity between A and C. So remember, average velocity here, average velocity is equal to distance taken over time. I mean total distance over time taken. Here I say distance taken, but it's distance as in total distance. I'll put total distance. So it's total distance over time taken, and we know the distance, we did find it. It was this part, which is 294 over the time taken is from 0 to 14 seconds. So you divide that by 14, and the average velocity therefore becomes 294 over 14. So you use the previous answer, you get 21. Remember, velocity is meters per second. Sometimes some prefer to write it as 21 meters per second, the one with a -1. So that is that part. So if I can write my answer here, 1.2.3, it's 21, that is average velocity. meters per second. Alright, so that is that part. Let us look at the next question. And so that was 2 marks, as I said. Looking at the next question here, if I can erase that. Okay, now we're done with question 1.3. So this is a totally new question now. I mean 1.2.3 now is 1.3. Says a motor car is traveling at 144 kilometers per hour in a 90 kilometer speed zone. The driver suddenly sees a speed camera 80 meters ahead before the camera can read the car's speed. Calculate the deceleration required to comply with the speed limit before being caught by the camera. So we have a motor car, or a driver here, who's traveling at a speed higher than the speed limit. So he's traveling at 144 kilometers. So maybe if I can try to sketch this to say we have someone here, so we have something like this. So this is my velocity, this is my time. So it says a motor car is traveling at 144 kilometers per hour in a 90 kilometer speed zone. The driver suddenly sees a speed camera 80 meters ahead before the camera can read the car's speed. Now what is important to note here is, look at the units. You are dealing with kilometers per hour, you're dealing with meters. So you need to convert kilometers per hour into meters. So that's the first part. Kilometers per hour, convert it to meters per second, to meters per second. Now you need to know some basic thing. For example, whenever you're doing conversions, sometimes it is important to know the standard conversions. For example, if I say, how do you convert 72 kilometers per hour into meters per second? So if you want to convert 72 kilometers per hour into 20 meters per second, what you do, you say 72 times Remember, kilometers to a meter, you multiply by 1,000 over an hour to seconds is 60 times 60. That's how you convert. So which means if I want to convert 144 kilometers per hour, it's the same thing. You say 144 is equal to 144. Now kilometers to meters, you multiply by 1,000. Per hour, you divide by 60 times 60. It will give us meters per second. And what will be that? So I will have 144 times 1,000 over 60 times 60, and it's giving me 40, which is 40 meters per second. Now that is the part. What about if I'm given, in this case, they gave us two different sets. They said it's 144 kilometers in a 90 kilometer zone. So what about 90 kilometers per hour? Okay, I think I'm writing too close. Now what about 90 kilometers per hour? So you've got 90 times 1,000 over 60 times 60. So you must always know this conversion. 90 times 1,000 over 60 times 60, and then it gives me 25. So this is equal to 25 meters per second. So you see the conversion. So whenever you're converting kilometers per hour to meters per second, you see that what you do, you take your kilometers, which is x kilometers in this case, you multiply by 1,000, you divide by 60 times 60. So this is what keeps changing. Alright, so now if I go back to my diagram, we have a car that is traveling here, just to fit everything here. We say, if I can read, a motor car is traveling at 144 kilometers. So we have here 144. So this is meters per second. So now I'm going to change that 144, and we said 144 is 40 meters per second. So he's traveling. Initially we say this guy already traveling, he sees a camera while he's traveling at 40 meters per second in a 90 speed zone. So I'll do this to say this was the cutoff, like that, and the cutoff speed is in here 90 kilometers per hour, but we converted that to 25 meters per second. So he is traveling at 144, which is 40 meters per second, and the cutoff speed is 25 meters per second. So he sees the camera. Now the moment he sees the camera, he starts slowing down before the camera can notice him. So that is how he starts slowing down. So there is a certain time that he took to ensure that he complies to 25 meters per second. Now the question here says, calculate the deceleration required. It says calculate the deceleration required to comply with the speed limit. So this is our speed limit here. So you cannot pass that speed limit without being hit by the camera. So they say calculate the what? The deceleration required. So now if you come back to our formulas here, deceleration or acceleration, and that is linked to 80 meters, which is this distance. You've got two equations, the first one and the second one. The first one has to deal with time, but since we're not told what is time, we're given s, so I can use the second equation. The third one, which says v squared is equal to u squared plus 2as. Now I've got the information. and in this case the final velocity, which is my v, the initial velocity, which is my u, and the distance, which is the area under here, they told us it is 80 meters. Getting that? So if I now substitute, we are saying final velocity, which is 25 squared, is equal to initial, which is 40 squared, plus 2a, and then the displacement is 80. Now we have to solve. Take 40 to the other side, which is 25 squared minus 40 squared is equal to 2 times 80. You can multiply or you can leave it like that as 2 over 80. Now for you to be able to solve this, you have to remember you are interested in acceleration, which is divide by 2 bracket 80. That's what you want to remain with a of 2 bracket 80, so that the 2 cancels this side and the 80 cancels this side. So what you're left on the right hand side is now your a, which is 25 squared minus 40 squared over 280. You can already keep using your calculator, like what is 25 squared, what is 40 squared, but sometimes it is also easier to always use the final calculator once, like that, so that you don't have to keep on writing lots of numbers. That's what I prefer. And when you do that, you get acceleration is minus 6,09394 to 2 decimal places, minus 6,094. So it's negative 6,094. Now its acceleration, remember, is meters per second squared. That is acceleration. Now the question is calculate the deceleration. So we are saying deceleration is equal to, that's why the answer is negative, because it is slowing down, which is 6,094 meters per second squared. By saying deceleration, already we know we are talking about a car that is slowing down. So guys, this is how you answer these questions. As I said, I've done already 2 sessions of this part, so this is the last part, part 3, and I will encourage you to check all these videos and use them for your revision. Now I've come to the end of the lesson, and remember to subscribe to our channel as well as turn on that notification bell so that you can be notified every time there's a new video. And also guys, don't forget to share the channel with your friends and colleagues, and also if you've got some questions and comments, remember to leave them below so that we can always assist you and revert back to you. Thank you.